So question 2 we were discussing. In question 2, we have the 4 resistors which are having the equal resistance. How will the powers of the resistor changes when W is removed? So if we say all have the resistance, because either you can use the values or you can use the variables to solve this question. Now, the total resistance of the circuit, this is R by 2, this is also R by 2. So the total resistance of the circuit is equals to R. So when the total resistance of the circuit is R, we said that the current which is passing is I. This current will divide here I by 2 and this current will be I by 2. And then this will be I here and the same current will be I by 2 here and the current will be I by 2. And then it will flow. Return will be I. If we work out the power right now, if you use a formula, because if either one of the formula I can use, if I'm using a formula P is equals to I square R, the power dissipation formula I'm using, as a resistor produce heat energy. So if I'm using a formula P is equals to I square R, so the current here is I by 2. The current here is I by 2, like example, this will be I by 2 square. And the resistance here is R, for if I'm finding for X. So what will be the answer here? I square. So this will become I square R divided by 4. So that is the power of X. And same thing, the power for Y and Z, because they also have the same resistance and they have the same current, I by 2. So if I work out the power of Y, so that will also be I by 2 square into R. So the P is equals to I square by 4 into R. We get the same power for X and Y, I square R divided by 4. Now in the question, if we remove W, so if the W is removed, this resistance is R, this resistance is R, and this resistance also R. The combine of these two will be R by 2, and the total resistance now, the total resistance of the circuit, which is R plus R by 2, that is equals to 3R by 2. That is a combined resistance. If the combined resistance is 3R by 2, what will be the total current now compared to the first circuit? Because of if the first circuit, the current was I. When the resistance, the total resistance of a circuit was R, the total current in the circuit was I. Now the total resistance of a circuit is 3R by 2, means 1.5 R. So what will happen to the total current in the circuit? It will decrease by 1.5. So this will be I divided by 1.5. Is it clear? The new circuit, when W is removed. So it will be I, because if the resistance is increasing, the current will decrease by the same factor. If a resistance is 1.5 times, the current will decrease by 1.5. So we can also say the current will be 0.66 I, the new current in the circuit. So 0.667 I, we can say that. So now the current is 0.667 I. That current which is flowing, the same current will flow here. So this will be 0.667 times the original value. Then when it will pass, that will divide into 2. This will be 0.33 I and this will also be 0.33 I. And the resistance of each one is R here. The combined is R by 2, resistance of each one is I. Now we find the value for the power of X. So we use a formula P is equals to I square R. The current here is now 0.667 I square. And what about the resistance is R? So what's the answer here in terms of the fraction 0.667 square. Use a calculator. 0.667 square. So 0.44. So 0.44 I square R. And what was the power when we calculated the X? Initially, when we calculated the X, what was the power? It was, if you remember, it was initially when we calculated, it was I square R by 4, which is also 0.25 I square R. So when you compare the power now with the original power, what happened to the power of the X? Initially, it was 0.25 I square R, but now it is 0.44. So what will happen to the power of the X? The power of the X has increased. And when we compare the power of the Y or power of the Z, if we compare the power of the Y, so we use a formula P is equals to I square R. What is the current here? The current is 0.33 I square and the resistance R. So 0.33 square. What's the answer? 0.33 square. So the power here is 0.12 I square R. So the new power of the Y is 0.12 I square R. And originally, when we calculated the power, it was 0.25 I square R. So what happened to the power of the Y or power of the Z? The power of Y and Z have decreased. Next is question 3. Next is question 3. In a circuit, X and Y has a length L. Uniform resistance R1 and R2 are unknown resistor, and J is a sliding contact. So this is a potentiometer, like the ratio of the resistance and the ratio of voltage is always same. Like R1, and if we say voltage here is V1, if we say voltage here is V2, and the resistance is R2. So we can say, because the ratio of the voltage in series is always same as the ratio of resistance. So we can say V1 over V2 is equals to R1 over R2. And what about the ratio of the resistance here? Because this is unknown. But the idea in a potentiometer, whenever this shows a 0 volt, it means the voltage, there's no potential difference. Like resistance of this part is same as resistance of this part. And resistance of this R2 is same as resistance of this part. That is what happened in a potentiometer, that if I draw, this is a variable or a fixed resistor or a wire, and I have a sliding contact here. And we place the two resistors. So the rule is that resistance of this part and the resistance of this part will be same as the resistance of the second part. So that there is no potential. If there is no potential, what the meter will read? It will read 0. When these two parts have the same resistance and this one is also having the same resistance, then the potential will be 0. There is no potential difference here. So we just simply use the formula that V1 over V2 is equals to R1 over R2. Now, the resistance of R1 will be same as resistance of this part. And we know resistance is directly proportional to length. So the resistance of this part will be same as the ratio of a length of this part. So we can also say that V1 over V2 will be equals to L1 over L2. The ratio of the resistance or the ratio of the length will be same as the ratio of voltage. What about length L1? The length L1 is X here. What about length L2? The length L2, the total length is L and the distance here is X. So what is this length? It will be L minus X, the difference. So if we substitute V1 over V2, the first length is X and the second length is total length minus X because we need the length of this section. So V1 over V2 is equals to X divided by L minus X. So it matches with option D. Resistance is directly proportional to length. So higher the length, greater the resistance. We want a ratio between V1 and V2. So if we want a ratio between V1 and V2, so V1 over V2 will be equals to R1 over R2. And R1, resistance of R1 is same as the resistance of this section. And resistance of this section is directly proportional to length. So R1 is proportional to X. And what about R2? This resistance is R2, so it is proportional to length of this section. What about the length of this section? Total is L, and here is X, so this will be L minus X. So we can say V1 over V2 is equals to X divided by L minus X. So the ratio of the voltage and the ratio of a length, if it was V2 over V1, if the question was V2 over V1, then option C will be the right answer. But the question is V1 over V2, so the ratio of the resistance and the voltage is always same. Question 4, any doubt? Question 4, 5. Question 4, a cell of EMF and internal resistance R is connected in series with a switch S and external resistor R. The potential between P and Q is V. So the external voltage is V here. When switch S is closed, when we close switch S, now the current start to flow. As the current start to flow, what will happen? There will be some loss voltage because you have the formula that EMF is equals to V plus IR. So what will be V? V will be equals to EMF minus IR is equals to V. So when the current start to flow in the circuit, the current increases. If the current increases, this whole factor will increase. If this whole factor increases, E is constant, the EMF is constant. So if this whole factor increase, what will happen to external voltage? The external voltage or the potential will decrease. So why the potential, the external voltage is decreasing? Because there is always some loss voltage within the internal resistance. So, there's always a loss voltage in the internal resistance if there's a current in the circuit. If there's no current in the circuit, there is no loss voltage. So when we check the options, V decreases, that is right, because the potential across R is increasing. Wrong. Because the potential across the R depends on how much voltage is lost internally. If there is more voltage lost internally, less voltage will drop externally. So here what happened? As we close the switch, so EMF is E and the voltage here is IR. As the current start to flow, so more voltage loss internally. If more voltage loss internally, less voltage will drop externally. So V decreases, that is right, because the potential across R increase, that is wrong. Because R potential is not increasing, the potential across R will decrease. The external voltage will decrease. The V decreases because there is a potential across internal resistance, that's right, as there is some loss voltage internally. So the battery will not provide the same output voltage. The voltage output of a battery will be less than what is labeled. Like example, if this is 3 volts and if 0.2 volts is drop internally, so how much voltage will be there external? The external will be 2.8. If this is 0.3 volts, how much voltage will be there? 2.7. If this is 0.4, how much voltage will be there? 2.6. So if more voltage drop internally, less voltage drop externally. The external voltage will decrease. So that's why B is, its remain constant is totally wrong. So that's why B is the right answer. Why not A? Because if there is less V is the voltage, external voltage. So if a V is decreasing, it means this voltage is also decreasing. That is the output voltage across the cell. So if the cell is losing more voltage, if you connect a voltmeter here, yeah, potential between P and Q is the external potential, external voltage. So what is, like, let's say when the switch was open, the potential was 3 volts. That is a, right now we have the formula EMF is equals to V plus IR. When the switch is open, there is no current. If there is no current, this value will be 0. In that case, the EMF will be equals to external voltage. But when we close the switch, the moment we close the switch, the current start to flow. As the current start to flow, there will be a voltage internally. So the total 3 volts, which was there, the EMF, and here was 0, so this was 3 volts. But the moment we close the switch, the current start to flow. As a result, there is some voltage internally, maybe let's say 0.2 volts. So if this is 0.2 volts, what will happen to external voltage? The external voltage will be 2.8 volts. So the voltage across PQ is same as the external voltage. So V will decrease, and because the potential across the R is decreasing. And why the potential across R is decreasing? Because there is more voltage across the internal resistance. Question 5. A cell, 2 resistors, equal resistance, and an ammeter are used to construct 4 circuits. The resistors are only part of a circuit that have resistance. In which circuit the ammeter shows the greatest current? Equal resistors are there, 2 resistors of so this is R and this is R. So the total resistance is 2R. What is the total resistance of this circuit? The total is actually, if ammeter is having a negligible resistance and we connect in this manner, so the current will flow this path. It is called a short circuit, like, because current always flow through the least resistive path. So it will flow in this manner. So the resistance of this circuit is R. What about resistance of this circuit? 2 resistors are connected in parallel. So the combined resistance will be R by 2. What about resistance of this circuit? The combined resistance will also be R by 2 because they are in parallel. Now we want the greatest current. The current and resistance are inversely proportional. So the circuit which is having a least resistance should have the highest current. So it cannot be A because A is twice resistance. It cannot be B as well. B is also having a resistance R. So either C can be an answer or D can be an answer. So what will happen if the current here is I? The current, because they are branches, so the current will divide equally. So the current here will be I by 2 and current here will be I by 2. But if the current here is I, this will divide into I by 2 and this will also divide into I by 2. The question is, which ammeter shows the greatest reading? So the answer is D. So first we find the circuit which is having a least resistance should have the highest current. Because C and D have the least resistance, so they should have the highest current. But in C, the ammeter is connected with one of the branch resistor. That's why the current will divide. Where in D, the ammeter is connected next to the battery. So it will record the maximum current which is coming out from the battery. Or maximum value of the current. Is it clear? So first rule for finding the maximum current is check for least resistance, and the second check the branch and the total input. Okay. Question 6, any doubt? Question 7. The diagram shows a potential divider circuit designed to provide a variable output. Look, these two resistors have a resistance of 5 ohm and 5 kilo ohms. So if we have a 9 volt supply, the total voltage will be 4.5 here and 4.5. That is a max. Why it is a max? Because this is a maximum value of a resistance of the two. So what will the maximum output here? The resistance here cannot be changed by, this is, as you can see, the diagram shows a potential divider, which row gives a variable range of output. So this is 5 kilo ohm and 5 kilo ohm. Maximum values are given. If they have the equal resistance, so this will have maximum 4.5 and this will also have maximum 4.5. Like not this maximum, but the voltage here which is divided will be 4.5. Now, which row gives the variable range of outputs? So if I reduce the resistance, to 0, so what will be the voltage here? The voltage will be 0 and the voltage here will be 9. So how much the voltage can be changed, the output voltage can be changed across the variable resistor. So maximum it can be changed from 4.5 to 0. So maximum will be 4.5 and the minimum will be 0. So B should be the right answer. Because the other resistor is a fixed resistor. The value of the fixed resistor cannot be changed. Only variable resistor can be changed. So I can never have a 9 volts here. Why we cannot have a 9 volts here? Because the resistance can never be 0. This is a fixed resistor. If this was having a resistance 0, so maximum 9 volts will be here. So practically it is impossible to have a 9 volts. So one fixed resistor and one variable resistor, initially they have the same resistance, so they will have the same voltage. But then if the variable resistor value resistance decreases to 0, so the voltage here will be 0 and voltage here will be 9. Variable resistor is a component which resistance can be changed. Fixed resistor resistance cannot be changed. So when we change its value from resistance from 5 to 0, the voltage here will decrease from 4.5 to 0. Is it clear? Question 8. In question 8, we have a diagram shows a circuit with a 4 voltmeters. So if we write the equation here, the total voltage is V. The voltage here is V1, total voltage here is V2, and voltage here is V3. Actually, this circuit is a combination of a parallel and series. We have two resistors with the R1, R and R, 2R, and we have another resistor R is there. If total voltage is V, voltage here is V1, we can say voltage here is V2 and voltage here is V3. But remember, V2 and V3 will have the same values. Why? Because it is connected in parallel. So this V2 and V3 will have the same value. So if I want to write an equation, I can say V will be equals to V1 plus V2. Or I can also say V is equals to V1 plus V3. Because the total voltage V divided in parallel, and like some of the voltage will be there across the parallel and remaining voltage will be there across the series. So V is equals to V1 plus V2 or V equals V1 plus V3. So which equation relate the voltmeter reading must be true? If I say V is equals to V1 plus V2 plus V3, that is wrong. It cannot be V3 because this should not be there. Because V2 and V3 have the same values. And the total, according to a Kirchhoff's second law, the total EMF must be equals to total potential in a loop. Like if I take loop 1, when I take loop 1, this is loop 1. If I take loop 2, I can take loop 3 and I can take loop 4. So according to Kirchhoff's law, the total EMF or is equals to total potential in a closed loop circuit. So if I take this as a loop, the red one, so V is equals to the total EMF is V is equals to V1 plus V3. Or if I take this as a loop, so the total EMF V is equals to V2 or V1 I can write first plus V2. That is how the voltage should be. So this is wrong. This is also wrong because V2 and V3 cannot be in the same loop. As you can see, they are in the different loops. When we check the third option, V3 is 2 of V2, twice of V2. That is also wrong. Actually, V2 should be equals to V3. They are in parallel. So when we are left with V is equals to V1 plus V3. So if I move V1 other side, so V minus V1 is equals to V3. So the total EMF will be equals to total potential in the loop. Is it clear? So option D should be the right answer. Question 9, question 10, question 10. In question 10, two lamps are connected in series. So when you connect the two components in series, the voltage will divide. One of the lamp is labeled the supply is 250. So if it's a 250 volt supply, if it's a 250 volt supply, one lamp is rated 240, like it need 240 to work normally. Another lamp is rated 2.5 watt and 10 volts, so it need 10 volts. Which statement most accurately describe what happened? If I have a 250 volt supply, in one of the lamp I need 240, another lamp I need 10. Is it possible to connect these two lamps in series? Yes, it is possible because the total is 250. So that 250 volts will divide in series. One resistor or a one will have 240 volts, another one can have 10 volts. So this is a possibility is there. So both lamps light as their normal brightness, less than their normal brightness, because this 250 can divide into 240 and 10. So it means the both lamps can light with a normal brightness, not less than a normal brightness. Both lamps light normally. Yes, that is the right statement. Like more accurately explained that because this is a possibility. But what if I was having the two lamps? One was, and I was having a supply which is say 100 volts. So if I was having a supply of 100 volts, in that case, what will happen? That because this for a normal brightness, it need 240 and for normal brightness, it need 10. So this might have a 10 volts, but this will not have 10, it will have a 90 volts. So as a result, what will happen? That the brightness of one lamp will be different from the other. Or not normal brightness. But because the supply is 250, 250 volt can be divided into 240 and 10. That's why the both lamp will work normally. And 10 lamp blow, it is only possible if I was having a 10, if I was having a 10 volt lamp with a power of 2.5 and I connect that to 240 volt supply. If I connect this to 240 volt supply, this 240 is more than enough, then this is a possible answer. If I was having only a 10 volt lamp and I connect to a high voltage supply, yes, the 10 volt lamps will blow. So both lamps will work normally as the total voltage is equals to sum of voltage across individual. Question 11, any doubt? Question 12. Question 13. Question 14. Question 15. No doubt?